Good afternoon, guys. It's Damien here from Donkey Racing Engines. We're down here with John from JSR Racing to flow and test our baseline 243 cylinder head for our Senator Turbo build. After we had our initial flow tests, we found the 243 heads had very turbulent flow after 500th hour lift. We started porting them, but ended up swapping out for a 241 Cathedral port CNC head by Chris Milton. Then we started to proceed with the build and getting our bits and pieces. We went with a PPE forged 4340 crankshaft, a 4340 H-beam conrods, CP Carrillo pistons. We welded the reluctor onto the crank just to make sure it doesn't spin. Then we got all our machine work done, torque plate, bore and hone, all the usual things to fully blueprint the motor. We kept the original LS2 block, clearance it all for the stroker. We had a line bore and a line hone done to suit the main studs. Make sure that's all right. So here's some pictures of our build when we were proceeding with the engine build. Once we had pretty much the short motor assembled, we picked our cam. We went with a custom grind 231, 237 at 50 on a 115 with around 620 lift. Yeah, we put head studs in there. We ran an LSA 7-layer MLS gasket, running standard LS7 style lifters. The Cathedral port heads, we have a dual PSI spring, double row timing chain. We painted all the accessories black. We welded on some Dash 10 rocker cover breathers. Then we ordered our kit from Killaboost, which was a T6 kit. Very, very good looking kit. Come with a 76mm Plasmaman front mount intercooler. We had a 60mm TurboSmart ProGate. They supply the cold side piping. We got to dummy it up on the motor while it was on the engine stand. We went with an 80mm S480 Pulsar Turbo. Went with a trunnion upgrade on the rockers as well. Once we had it all dummied up, we were able to set our base spring pressure. We were able to use Speedflow 200 series fittings throughout the turbo oil feed and drain. Once we could mock everything up on the engine stand, it was quite easy for us to be able to then just drop the motor straight in. We modified the standard outlet for the oil feed with a 1mm restrictor. We made custom high tension leads with fiberglass boots to keep the leads as tight as possible into the cylinder head to avoid that dump pipe. Then we could drop the motor in the car and start the rebuild, remove all the old supercharger components, and we were able to fit the Killaboost kit up with no worries. That just worked, no problems at all, no clearance issues. We were able to dummy the intercooler fit, get some brackets on there to make sure that sat in the right spot. Once we were done with that, we needed to get a dump pipe made, so we sent it down to Andy from Admo Fab for a custom dump pipe. Now, we wanted to run 4-inch and split into twin 3-inch. We already had a twin 2.5-inch cat back, so we were able to get Andy to make a 4-inch dump, split it into twin 3-inch, then split it back down to the twin 2.5-inch to suit the existing cat back. We do plan eventually to put a twin 3-inch system on there, but at this stage we're just going to run with the exhaust we had. We were then able to use some coil covers, make up some nice heat shields for the dump pipe. I did spray the inside of the dump pipe with a heat-proof coating. We were able to use some of the gold reflective heat tape on the transpan and a heat shield around the two crossover pipes as well. And once that was done, it was pretty much oil test, a few little wiring modifications to the battery charge cable, and here we are. So we've just got the Senator running. We have done a run-in tune on the roller dyno. We've batched off the oil. We're running a ULX 110 30 weight run-in oil currently. So this is the forged 403 cubic inch LS2 base stroker with the Pulsar S480 Turbo on it. Seems to be idling away nicely at the moment. Done a fair bit of work to make sure things run smoothly. It's got a nice bit of idle chop to it. Nothing too aggressive. The customer wanted it to sound like a real V8. So we're about to just do our final check on, make sure everything's working alright, and get it bolted onto the hub dyno. Ready to get the full power sent to about 7 pounds for a run-in period. So we've come in early now. We were doing some tuning on it yesterday, and we put a 4 psi spring in the 60mm wastegate, and just for run-in purposes, and it made 4.8 psi boost. Now, when we have a look at the data, the 4 psi run is in the red. It made 677 newton meters, and the converter was pretty good. The standard converter didn't hate it. Now, if I started the run in the yellow here and I held the run for about 3 seconds, I was able to flare past the standard stall about 3300, and it made 8.5 pound, tapering off to 6, and the torque jumped up to 787. Now, if I held it for about 5 seconds, I was able to build the boost about 13 pound. The standard converter went to 4000. It made 500 kilowatts, but it pushed over 1000 newton meters of torque. So I'm a little bit worried about ballooning the converter, so we're going to pull the wastegate off, and we're going to just chuck a 12 pound spring in it straight off the bat. So we found the softest spring we had in our box of springs, and that's what was giving us 4 psi. It's pretty soft, pretty squishy, doesn't have much tension, so we'll find something with a little bit more tension. Probably try this blue one next. We'll put it in the gate, and then we'll use our little test rig to see where it cracks and where full stroke is on the gate, and yeah, see if we can get about a 10 to 12 psi worth of boost pressure in the wastegate. So we have it in the vise and some soft jaws. I put the compression ring back in because it sort of sits like that and it puts extra tension on the spring. So we'll start dialing up the air pressure, and we'll watch to see where it cracks, and we'll see when the gate starts moving. So it's cracking about there, which is about 10 to 12 psi on our little gauge, and then we go a little bit further and we get full stroke at about 20 psi. Now that's probably going to be too much for this run-in, so we'll try a different spring. So we've played around with the springs. I added a small spring to our loose spring, and we went from 4.5 to 5.2. Not really enough gate pressure without really loading the converter too hard, so I've taken the gate off again. Nice and hot for us, and yeah, we're on 7.3 psi now. The interesting part about that was when we tested it on the bench, it was cracking at around 10 to 12 and full stroke around 20. Now what that's sort of shown is to get a 7 psi worth of spring, it's got quite a bit of exhaust gas back pressure behind it pushing on the back of the wastegate valve. So I think 7 psi is enough as a gate pressure to start with. We're still not running a boost controller, it's still just running standard gate pressure for running. It's still making 450 kilowatts, so 600 horsepower. If I load up the converter a bit harder, it will make more boost, but at this stage I think we will run it around 7 pound, shake the car down a little bit, then we'll add our boost controller and go from there.